Flying the airplane is the name of the game, so let's take a closer look at what the flight instruments on the PFD tell you in the air. First of all, notice this really big horizon line stretching all the way across the PFD. The blue part represents the sky and the brown represents the ground. Makes sense, doesn't it? And these yellow lines represent your wings, and the yellow triangle represents the nose of the airplane. Now, these horizontal white lines show degrees of nose up and nose down pitch. The big lines show 10 degrees each, while the smaller lines show 5-degree increments. Now, the semicircular scale here at the top shows degrees of roll. As the airplane rolls, this bottom triangle here points on the roll scale to show you your bank, and the marks on the scale are 10, 20, 30, and then 45 and 60 degrees of bank. Now put all of this together and you've got yourself an attitude indicator. Now, both things a turn coordinator tells you are shown on the PFD, but in two different places. To know if your turn is coordinated, you look at this small bar under the roll pointer, and it tells you the same thing as the ball in a turn coordinator. The bar moves to the left and right, telling you when you're not in coordinated flight, and to center the bar, you step on the bar just as you would the ball in a conventional turn coordinator. And for your rate of turn, you look here above the compass card. This magenta arc shows your rate of turn. Here's a half standard rate, here's a full standard rate, which is 3 degrees a second, and when it gets faster than 4 degrees a second, the line doesn't get any longer, but an arrowhead shows up to tell you you're exceeding 4 degrees a second. Now, on the left side of your great big attitude indicator, this vertical tape is your airspeed indicator. And the airspeed tape moves up and down as your airspeed changes. This box here shows your indicated airspeed, and at the bottom of the airspeed indicator, you see your true airspeed, which the G1000 automatically calculates for you. And the white and green and yellow and red speed ranges are shown here on the right side of the airspeed indicator. Now, these speed ranges tell you the exact same information as the arcs on a round airspeed indicator, except for two things. First, you'll see a red range below the white speed range. That shows you airspeed slower than stall speed in the landing configuration. Second, the entire range above the never exceed speed has a red and white barber pole. And if you go past the never exceed speed, the indicated airspeed box changes to red. Now, there are also 4 other airspeed markings called V-speed references, and these 4 bugs indicate the speeds for rotate, best angle of climb, glide, and best rate of climb. Each of these speeds is tacked onto the airspeed tape at the appropriate place. Now, you can change the speeds on any of these reference bugs if you want to by pressing the timer reference soft key, which is where you can also choose to show or hide each of these speeds, but you can't change the letter in the box. Now, over here on the right side of the PFD, this vertical tape is the altimeter, and you can see it looks very similar to the airspeed indicator. Your current altitude shows up in this box, and the altitude tape moves up and down behind it. You'll find the altimeter setting here at the bottom, and you set that with the baro knob. The number on top of the altimeter shows your target altitude, and you use the big and little altitude knobs to set your cruising or assigned altitude into this box. And that also sets this altitude reference bug, and this reference bug makes it easy to recognize your target altitude with just a glance. And now, when your reference altitude is off the scale, the reference bug stays at the top or bottom of the scale until your target altitude comes back into view. Now, to the right of the altimeter is your vertical speed indicator, and the scale shows up to 2,000 feet per minute up or down, and this pointer points out your actual vertical speed. And when your vertical speed is more than 100 feet per minute up or down, then this number inside the pointer shows your actual vertical speed in 50-foot increments. Now, for guys like me, this pointer is moving all the time, and the pointer pegs out at 2,000 feet a minute up or down, but it does continue to display your actual vertical speed. Now, below your attitude indicator on your PFD is this, your horizontal situation indicator, or for short they call that the HSI. Now, in HSI shows your magnetic heading, the course you've selected, and any deviation from that course, all in one package. Now, at the top of the HSI, you see your actual magnetic heading, and here is your desired heading or your heading bug, and you change that using the heading knob. Now, notice that the heading box gives you a 3-digit display to help you put that heading bug exactly on the heading you want. Now, here is a handy trick. Push on the heading knob, and the bug snaps to your present heading. Now, to set your desired course, you use the course knob, and that will change your desired course. It also has a 3-digit box, and pushing on the knob will snap the course directly to your waypoint. Now, there's a lot of navigation information here on the HSI. Of course, it has a CDI or course deviation indicator. It also has your navigation source, in this case NAV1, and the course you have selected is at the head of the arrow, and the to from indicator shows the direction to the fix, in this case ahead of you. And the course deviation bar, or D bar as Garmin calls it, slides across the scale to the left and to the right to show where the course line is relative to your position. In this case, you'd have to turn to the left to get back to the course you've selected. Now, to cycle through your navigation sources, you press the CDI soft key, and you can choose GPS, in this case GPS terminal. You can choose NAV1 or NAV2, and you notice that your choice shows up here on the HSI. Notice the HSI displays the GPS CDI in magenta, but the NAV1 and 2 VOR CDIs are green like this. You also see the green radio frequency in the NAV frequency window, and it shows what you have chosen, and it corresponds to what you have on the HSI. Now, when you choose NAV1 or NAV2, the scale is the same as a mechanical CDI. But when you choose GPS, the full scale limits on the CDI depend on whether you're in en route, terminal, or approach mode. And we'll talk in more detail about that later. And finally, if you do not have an active navigation source, which means you're not receiving a radio nav aid or you don't have an active GPS course, that deviation bar disappears altogether, leaving you out in the cold. Now, earlier we talked about how to tell your rate of turn. Well, that magenta arc is actually what is known as a trend vector, and you'll see that in other places too. A trend vector predicts where your current rate of movement will take you over a specific period of time, and the G1000 trend vectors show you what will happen in the next 6 seconds, and that can really help you smoothly manage your pitch and power control. So, for example, you can use this trend vector to make half standard and standard rate turns by comparing the trend vector here to these two reference lines. A standard rate turn is 3 degrees per second, by the way, and that means in 6 seconds you'll have turned 18 degrees. So this reference line for a standard rate turn is 18 degrees off of your current heading. So actually what this arc shows you is the heading you'll be on in 6 seconds at this rate of turn. Now, you'll also find trend vectors on the airspeed indicator and the altimeter, and on the airspeed indicator it tells you your airspeed 6 seconds from now. And on the altimeter, it tells you what your altitude will be in 6 seconds from now. Now, during normal flying, these trend vectors are really pretty subtle. Unless, of course, you're flying with me, in which case they can get really big. And if those trend vectors do get really big like this, well, you'll also likely see some big changes on the PFD. First of all, you'll see these big red chevrons, and they warn you when the nose of the airplane is either 50 degrees up or 30 degrees down. And they may be just giving you your first clue that you are in an unusual attitude. And the chevrons point towards the horizon, telling you which way to move the nose to get back to the horizon. Now, also, anytime the airplane exceeds 30 degrees nose pitch up or 20 degrees nose pitch down or 65 degrees of bank, all but the essential flight indications will just disappear from the PFD. So just about everything unrelated to pitch and bank will go away until you bring the wings and nose back closer to normal flight. So you'll lose things like the inset map and the flight plan window and alerts and the transponder. And that's one way the G1000 has of telling you, straighten up and fly right. This all might seem pretty complicated, but soon you'll be comfortable using the primary flight display and it'll all become second nature.